Hello, welcome back to Cracking the Cryptic, and an approachable puzzle today. We occasionally get implored. There was one comment on a recent video I did that said, please do more approachable puzzles. I want to not have to think about it or something. It was like, well, I guess that's not normally the point, but there's definitely room for a spread of abilities. That is unquestionably the case. In the world of variant Sudoku, let's get involved because it's such good fun. And this one is apparently achievable. Anybody could solve this. That's what we reckon. And we're going to recommend it to you. If you haven't tried one of the puzzles on the channel, you've just watched us solve them, this is a good one to dip your feet in the water and give it a go. It's a new constructor, Keaton Asbach, and in fact, the tester apparently removed 3 given digits and said Mark won't need those. So there we go. There are no given digits in this puzzle. Just a bunch of thermos, but a slight extra rule. So I will go through the rules in a minute. If you find yourself loving this when you're solving it, do remember that we have a Thermo Sudoku app, which has lots of puzzles with these little wigglers on there. It's absolutely brilliant. They're by some of the best constructors around. Lots of a spread of difficulty within the apps as well, so earnestly recommended, along with our latest Fog of War Sudoku, of course. And if you want more content, every month on the first of the month in our Patreon site, there's a new Sudoku hunt. We have an oil and water Sudoku hunt for last month, well, for May, coming up in June. It'll be a yin-yang based hunt by Itrio. Really looking forward to bringing that to you. What else? There's, of course, loads of other stuff on Patreon. There's our crossword videos every month, connections videos every few days, and loads of other good content. SVEN'S Sudoku Pad you can support on a link under the video, and even our merchandise is available there, so do check it out. Now, what are the rules of Keaton Asbach's Thermomodness? It's not got modular lines, despite that title. The rules are these. Normal Sudoku rules apply, so that means putting 1 to 9 in every row, every column, and every 3 by 3 box. Digits along a thermometer must increase from the bulb end, so we get bigger as we go along a thermo. Now, here's the extra rule. The sum of digits along a thermometer must be a multiple of the length of that thermometer. So on this 3-cell thermometer, the sum of the digits will be divisible by 3. On this 5-cell thermometer, it'll be divisible by 5. Fine. Well, I mean, that's not higher maths. That's fairly basic arithmetic. Give it a try on the first link under the video. It is approachable. I keep repeating that. Maybe it won't be. I'm going to start now. Let's get cracking. So I think the thing to do is to look at the longest line, and that's this one. 1, 2, 3, 4, 5, 6, 7, 8 cells. Right. First of all, how much can it add up to, possibly? And to compute that quickly, you'll need to know a secret that I'm prepared to share with you, that the Sudoku digits 1 to 9, which populate every row, column, and box, and would populate a 9-cell thermo, always add up to the same total, and that is 45. Now, here on this line, we need a total divisible by 8 when we take one of the digits out. 1 to 9 can't all appear on this line because it's 8 cells long, so we're going to remove one of the digits. So 45 minus something gives a total divisible by 8. Well, I think that total divisible by 8 must be 40. And therefore 45 minus 45 is the digit that doesn't appear on the thermo. And literally we can fill in the other digits that do. I suspect the rest of the puzzle won't quite give us this entry level, but that's a decent start. Okay, there is no other thermo longer than 6. So there's a lot more variability on the other possible thermos in terms of the total. Let's actually just look at the central box and ask the simple question, where does 9 go? And it may be useful to realize that in a thermo Sudoku, 9 can never appear on a thermo except at its very end. 1 can never appear on a thermo except in the bulb at the beginning. So 9 in this box can't be there or in any of those cells, and it must be there. 8 in the box, 8 doesn't have quite the same strictures. It could be in the second last cell of a thermo, but not on this one because that digit can't be 9. So I'm putting 8 there. Similarly, this can't be 7 because you can't put 8 or 9 here. So 7 is there, and now I can do some arithmetic. 9 plus 8 plus 7 is 24. I've got 4 or 5 left to complete a thermo that has to be divisible by 4. Or 24 is already divisible by 4, so another 4 will keep it divisible by 4. 28 divided by 4 equals 7. Then we get a 5 onto this thermo now. And we've finished the central box. I mean, that's a handy start. This digit has got to be bigger than 5 because of thermo rules, but not 9 or 8 by Sudoku rules. So that is 6 or 7. And now if we add up those possibilities, 6 plus 7 equals 11. I think we'd need a 1 or a 4 here to be less than that 5, but divisible by 3. This thermo is 3 long. I mean, this is maybe the tricky part, is you have to keep switching. So here we were looking for numbers divisible by 8, here for numbers divisible by 4. Now we're suddenly looking for numbers divisible by 3. And with the 6 there, I think those numbers are 12 or 15. With the 7, I think 753 does it. That's also 15. And I don't think any other possibility, well, I could have actually filled in those candidates based on that being a 2 and the thermo, so maybe it didn't really advance. The cause of human understanding much. Okay, 9, 9. Where's 9 in this box? Not on a bulb, that's for absolutely sure. It's there. Then, very simply, where's 8 in the box? We've got those two 8s, so it's in this row. It now can't be here because that thermo end can't be 9, and the little thermo wouldn't be divisible by 2. So I'm putting 8 here. It can't be there because you can't put 9 here. Now, I think I have to be a little careful about 7. I'm very tempted to write it in here. It certainly can't be before that on the thermo, or there'd be a gap before 8. It can't be here because that digit can't be 8 or 9. But I think it could be here. If that was a 7, this thermo would have to be 7, 8, 9. But that's 24 and is divisible by 3, so that is possible. So, oh, well, where's 1 in the central row? Actually, you could have just started with that digit in the whole puzzle, because there's only 1 bulb in the central row and every digit is on a thermo, so the 1 is there. Then we have 3, 4, 5 and 6 to place in this row. So on this thermo, let's just say 3, 4 or 5 there and a bigger digit here, 4, 5 or 6. And in the other cells I am going to put all the candidates, because never afraid to Goodliffe a thing. That means write all the candidates. Now, this digit has to be higher than 4, but it's not 5, 9 or 8. So that's 6 or 7. It might be worth adding up all the possibilities, and that seems to be 1 or 2 because it's less than 5, but it's not 3 or 4. So what could we possibly add up to on this line? And I bet it's 25. At the max, we'd have 8, 7, 6, 5, 2. And that's 28. At the min, we'd have 8, 6, 4, 3, 1. And that's 22. So this line, which has to be divisible by 5, falls between 22 and 28, and it must add up to 25. Right, the next thing I'm going to do is use the secret on the box. Because, I mean, I think there are some possibilities for how that can add up to 25. But let's add the 9, and we've got 34. The other two, remember this secret of 45, which is the sum of every box, because they all contain the digits 1 to 9. 34 from 45 means these two add up to 11. And now this can't be a 7 anymore, because we'd be left with 4, which would have to be 1, 3 on this thermo, and the 1s make that impossible. So that is not a 7. So the only place for 7 in the box is now here. These, I'm going to colour them. These add up to 11. Actually, this one is all this thermo is always providing an even total because it's a 2-cell thermo, so it must be divisible by 2. So this digit, 11 minus an even number leaves an odd number. This is 5 or 1 for definite. If it was 5, this would add up to 6 and would be 2, 4. And then this would be 1, 3, 6, 7, 8, and that would obviously add up to 25. So that's possible. Can that be 5? This would be 6 or 8. This would be 8 or 9. I mean, something there must be divisible by 3. I'm not even going to work that out. Oh, that 7 is looking at this digit, so that's a 6. 6, 11, that makes this 1 or 4. We've got 2, 3, and 4 to fill in the row. 5 here would require that to be odd. Okay, I can't quite resolve that. This is higher than 3, but it's not 4, 6, 8, or 9. That is 5 or 7. Okay, where do I go next? It's actually quite hard to move into other boxes in this. I suppose this one's interesting. The end of this thermo could be a 7, but other than that, it can't be higher than 5. So I'm going to write 7, 5, 4, 3 as possibilities. Here, 5, 3, or 2. And here we're down to 1 or 3. Oh, where's 9? 9 could be there, couldn't it? No, let's go down to the 6-cell thermo. That actually is the second longest thermo in the puzzle. I haven't really considered this, but 9 and 8 can't go in these cells by Sudoku. So they must go into these 6. Now you could hide one of them away there, but one of them's got to get on the thermo. And wherever 9 or 8 goes on this thermo, the last cell must end up being 9 or 8. Must do. Because, you know, try putting 8 or 9 anywhere on this thermo and what happens to the last cell. Even if you've put 8 here, it is an 8. If you've put 8 here, that's a 9. You can't put 8 or 9 anywhere before that. That's what I'm talking about. So that digit is 8 or 9. Where does this digit go in box 1? And it must go in those 3 cells because it appears here in box 4. And it can't be there because there are 2 cells higher than that on the thermo, so you couldn't put 8 or 9 there. So it's on this thermo, and it's the same principle here. If 8 or 9 is on this thermo, the second digit is 8 or 9. Might not be the same one as that, but it must force that to be 8 or 9 if it's not. Now, is there anything else we can do to think about this? 1, yes. Where's 1 in this column? It's absolutely straightforward. It can't be in those cells. It's not in this box. It can't be in those cells. It's there. There's a 1 somewhere down here. 1, 8, 9, 6. Now, this is going to be divisible by 4. That's going to be divisible by 2. Both of those are going to be even totals, so this is going to be an odd total. Don't quite know what to do with that. This digit is 2, 5, or 7. Maybe I could do more here. 7, 8. Just don't know. Can this be 5? That's really the question. then that would be 5. Ah, that is no good, is it? This digit here cannot be 5 because the end of the thermo would be a 7, and this would be 157 equals 13, not divisible by 3. So if that can't be a 5, the 5 in this row is over this side, and that bulb becomes a 1. That bulb becomes a 2. This thermo adds up to 10 because we knew that those orange cells were adding up to 11. So it must now be 4, 6. And this is 5, 3, and another box is done. We get a 4 here. Let's add up this thermo. 1 plus 4 is 5. We need to come to divisible by 3. So 12 is the number. This digit is now a 5. This is a nice puzzle. I like the way this unfolds. 8, 9, and 6. Okay, here's another thought. This digit is not 8 or 9 because this thermo would then add up to 17, which is not divisible by 2. So the other 8 or 9 in this box, which can't be on this thermo and can't be in those cells because of Sudoku, is here on the end of the next thermo, and that's an 8-9 pair. Everything else in the column is 2, 3, 6, or 7. And down here, I'm sure this can't be 6 or 7. There are too many digits higher on the thermo. So we've got a 2, 3 pair in the column. These other two are from 6 and 7. This, we can pencil mark 3, 4, or 5 there, 4, 5, or 6 there to make sure we're ascending, like the lark. I don't really want to add up this. I probably want to add up these cells and have them add up to 45 minus 6 times something. So they probably add up to 15 if this thermo adds up to 30. But they could, in theory, add up to 21. Oh, well, hang on. Where's the second 9 or 8 in this box now? There's one there, but the other one is not in these cells, so it's in the corner. Yeah, these could add up to 21 or 15 or 9. Well, they can't add up to 9 anymore. I see why this is modness, because I'm sort of doing modularity sums based on divisibility by 6 and the remainder in the box. That's quite interesting. I didn't know I would end up doing that. Right, let's just find something else we can do in the puzzle. This digit is 1, 3, or 6. It cannot be 9 because that would be too much in a bulb. There's a 7 in one of those. 6, 9, I'm sorry, this is probably easier than I'm making it. 6 must be on this. Okay, if these were to add up to 21, I think I can see that that would probably be 5, 7 there and 9 there. And then this would go 1, 2, 3, 4, 6, 8. And that does seem feasible. Maybe I add up this. 1, I don't know, 4, divisibility by 4 gives some variability. So all I know about this at the moment is it's 2, 3, 4, 5, or 6. I don't want to do that maths. These two, they can't both be 8 and 9, which would not only give a sum that wouldn't work, but would be impossible because of that. Nearly a good question to say where's 9 in the row, but there are 2 candidates. Okay, I'm sorry, I need to come up with something interesting that we can look at next. 4, 3, 8, 1, 4, 7. I mean, I think there are various places we could go. If these were to add up to 15, that's the possibility I didn't check, which would leave the 6-cell thermo adding up to 30. Then this pair would have to add up to 7 or 6. I mean, those look both very possible too, so maybe that isn't where to explore. Okay, if that was a 7, this would be 7, 8, 9, which is divisible by 3. Oh, sorry, I'm going a bit slowly now. This one, we've used 2, 5, and 8 in the column, so this could be 3, 4, or 6. It can't be 7 because this can't be 8. This one in turn can be 4, 6, or 7. Oh, where's 1 in this column? I mean, it's absolutely easy when you think of the right question, isn't it? And where's 9 in the column? Again, absolutely easy when you think of the right question. Sorry, column 8, I didn't notice how helpful you were. Right, that 9 makes this an 8. That sorts out these 8 9s. That's interesting. This 8 is on a 2-cell thermo, so this needs to be even as well. It's not 4, it's 2 or 6. This one now adds up to 10 plus 6 or 7. If that's a 6, this needs to be divisible by 4 and is a 4. If that's a 7, what have we got? 10, 17, that needs to be a 3 only. So that is 3 or 4. Now, in this column, surely we've got a triple or a quad or something. No. Okay, but these two, they could be a 5, 7 pair. Oh, yeah, I'm remembering that with that digit, they need to add up to either 21 or 15. Or they could be 1, 5 or 2, 4. So that's still not resolved. Okay, let's look at this row again now. 1, 9, 7, 4. Everything is from 2, 3, 5, 6, 8. Well, 8 must be in one of those 2 cells. We're on a 3-cell thermo with a 1, and therefore the other digit on one of those thermos is divisible by 3. Well, neither of them can be 9, and this one can't be 6. So either this is 3 with an 8 there, or this is 3 or 6 with an 8 there. That's weird. Actually, maybe let's come back to this column, where we had 3, 4, 6, 7 to place. This column was much more helpful than I'd been expecting a little earlier, but now I think less so. This digit can't be 4, 6, 8, or 9, but it's got to be higher than 3, so it's 5 or 7, and now this can't be 7. If that's 7, well, there's a couple of possibilities there. If that's 7, I don't know what to make of this. The 1 in this box is in one of those 2 cells. 3, 4, 5, 6, 7. 9 in this column. 9 is placeable now since we got that one in this column, and I'm putting it in at the top. Everything else is 1, 3, 4, or 8. Ooh. So this digit is either forcing this to be a 2 or this to be a 9. If that's an 8, this is a 9, and this is then 7, because it can't be 4 or 1, and they're the modular similarities. So this line could go 7, 8, 9. But if this is 3 or 4, this digit, which can't be 4, 3, or 1, has to be 2. And then 2, 3, 4 is impossible, so 7 would be the answer. Oh, if that is a 2, no, I was going to say we need a 7, but the 7 could be here. 2, 4, 6, or 9. I mean, we narrowed things down a bit, but not actually as far as I thought we might. So this is either 2, 3, 6, 2, 3, 9, no, 2, 4, 6, 2, 4, 9, 2, 3, 7, or 7, 8, 9. That's quite a lot of possibilities. This puzzle's messing with me a bit. Okay. That is 1 or 2 by Sudoku, obviously, since that's 2 or 3. I don't know why I haven't filled that in before. So what's going on then in the row? I mean, we've got lots of digits in the puzzle. There really must be a lot of ways of approaching this now. That is 2, 3, 5 or 6. This is 5, 6 or 8. This one can't be 2, so it's 3, 5 or 8. This one can be 2 if that's 1, 2, 3. We know that 8's in one of those cells, so the 8 in the top row is there. Now 8 is definitely in one of these two. Actually, that's been available for a little while. 8, 4, 7, 9. 1 has to be in one of those cells in box 2. I just need a breakthrough on one thermo and it's total, it's calculation now. I don't know which it is. Right, that can't be a 3 anymore, because they would both be divisible by 3, and that would also have to be divisible by 3, and there is no number smaller than 3 that is divisible by 3. So if that's a 6, that's a 3. If that's a 4, I think this is a 2 to get to 15. If that's a 7, this is 2 or 5. Ah, where does 7 go in the box? I think that might be answerable. It's clearly not there by thermo rules. It's not here by Sudoku rules. It's not there either. If 7 was here, this would be a 1, 7, 8 thermo. That adds up to 16, which is not divisible by 3. So 7 must be here. Now we know that this is either 2 or 5 to make this thermo add up to 18 or 21 and be divisible by 3. Down here, that can't be a 7. We've got 3, 4, 6. On the thermo, this can't be a 6 now. 3, 4, 6. We need a 9 in one of those two cells. We've got 1 over here somewhere. I don't know if this one's worth adding up yet with all the possibilities. This is now, actually this has to be less than 4, and it can't be 1 or 3. That's a 2. Right, this is Sudoku, and this is huge. 1, 3 there, and we run that up the flagpole. This becomes a 7, and that gives us 7, 8, 9, which was one of the possibilities we had marked in earlier. This has become a 4. That's a 1, that's a 3. That column is complete. This thermo is complete. Look, the only digit higher than 3 here is 5, and then we must go up to 7. That's a 6. Now I can add up this one. 16 plus a 4 there does the job. That's become a 2. I think this is just literally, that was the last step we needed. 6, 5. I mean, I haven't even added up this one, but I bet it's right. That is 30. So that's good. That's a 2, 4 pair. On the bottom row, that's a naked 6. That's a 5. That's an 8. We've placed 1 in the box. It's amazing how this suddenly comes together. That's not a 2. We've got, those aren't 5s. 3, 6, 8 still to place in the row. This central column, this is 2 or 6. It can't be a 2 by thermo rules, so it's a 6. That's a 2, 5 pair. Let's not forget the divisibility rule. This has to be even and is therefore 2. And there we go. 3, 9, 3, 1, 2, 6, 8. We've got 4, 5, 7 to place. This digit is a 4. That is a 5. That's a 7. This thermo adds up to 12. This one adds up to 20, which is fine. That's a 3, that's a 6, 8, 3, That has to be 2. 1, 2, 3, definitely divisible by 3. 5, 7, 9 also. 2, 5, lovely. That's really nice. I mean, it's not that hard, but it's very clever. Thermomodernists by Keaton Asbach, sorry. Excellent puzzle. Certainly didn't need any givens, but very entertaining and very approachable, I believe. Thank you for following us on the channel as always. Hope to see you again tomorrow. Absolute pleasure to be with you. Have a great, well, it's Monday night now, so have a great Tuesday. Bye for now.